Hey everyone, and welcome. Today we're getting into something that is absolutely fundamental to your website's security. Its address. It's the digital front door for every single person who visits you. And our job is to make sure that door not only opens, but always leads to the right place.
Okay, so to really get this, let's think about it in a really simple way. Imagine you own a real physical store. Now, what if one of your competitors could just go into Google Maps and change your address, sending all of your customers over to their shop instead? That would be chaos, right? Well, that's exactly the kind of problem we're talking about in the digital world.
And the system that handles all this is called DNS, which stands for the Domain Name System. Honestly, the best way to think about it is as the internet's giant address book. See, we humans are good with names, like example.com. But computers, they need numbers, specifically IP addresses. DNS is the translator in the middle that connects the name you type to the right computer server, wherever it is in the world.
All right, so for this first part, let's take a closer look at how this address book is actually set up and how it's supposed to work when everything is running smoothly. Now, this address book isn't just one big list. It has different kinds of entries, or what we call records. For what we're talking about today, the big one, the most important one, is the A record. That's the one that points to your website's main address. Of course, there are others, like MX records that handle all your email, and TXT records that are often used to help prove you own your domain.
But really, when we talk about people visiting your website, the A record is king. It is the one single entry that answers the most important question of all. Where is the website? Everything, and I mean everything, depends on this one little piece of information being correct.
And you know what's wild? This whole process happens in the blink of an eye. The second you hit enter, your computer shouts out to a server called a DNS resolver, asking for the address. That resolver goes and finds that critical A record, grabs the IP address, and sends it right back. And then boom, your browser connects to the web server. It's simple, it's incredibly fast, and hopefully it's accurate.
But what happens when it isn't accurate? And that brings us to our second section, where we're going to get into the common threats that target this very important system.
This is really the heart of the matter, isn't it? We've just talked about how vital that A record is. So what happens when a bad actor gets in there and decides to change that address in the internet's phone book? Well, that attack has a name: DNS hijacking. It's when an attacker manages to get in and change your A record. And the result? Your visitors, who fully believe they're going to your site, are quietly and invisibly redirected to a fake one that the attacker controls. And from there, they can try to steal passwords, credit cards, or spread malware. It's really nasty stuff. This slide just lays out the danger so clearly. On the left, you've got the normal, healthy process we want. But on the right, that's the hijacked flow. The only change is that the DNS system hands back a fake IP address. To your user, everything probably looks completely fine, but they've just landed on a server controlled by an attacker. And hijacking is not the only threat out there. In an attack called DNS spoofing, criminals can poison the data on the DNS resolvers themselves, which means they can redirect tons of users all at once. Attackers can also weaponize DNS servers to launch these massive floods of traffic. You've probably heard of them as DDoS attacks that can knock a website completely offline. Okay, so that all sounds pretty scary, right? The system is definitely vulnerable. But here's the good news. There are powerful ways to fight back. So in our third section, let's talk about the solutions that can lock your digital front door. Our first line of defense is a technology specifically designed to stop this kind of tampering. And it's called DNSSEC. Just think of DNSSEC as a tamper-proof seal on your DNS records. It uses these complex digital signatures to prove that the information, that IP address, really came from you and wasn't changed along the way. If a DNS resolver sees that the signature doesn't match, it knows something's fishy. It can just throw away the bad record and protect the user. It adds a critical layer of trust. All right, so DNSSEC is great for proving the address is real. But there's another really powerful defense, using a proxy. A proxy basically acts as a bodyguard, a protective shield that stands between the open internet and your server. The way this works is actually pretty brilliant. Instead of your A record pointing directly to your server's real IP, you point it to the proxy's address instead. Just by doing that, you completely hide your server's actual location. Now, all traffic has to pass through the proxy's massive network first, where it can be scanned and filtered for threats, like those big DDoS attacks we were just talking about. And this right here, this is what it looks like in a typical dashboard. See that little orange cloud in the word proxied?
That's it. That's your shield. That simple indicator is confirmation that the proxy is active. Your server's real IP address is hidden, and you are protected from all sorts of direct attacks. It's a beautiful thing. And this quote from our source material just sums it all up perfectly. Because that one little A record controls where all of your traffic goes, securing your DNS isn't just some techie IT task, it is one of the most critical security functions for your entire online business.
So we'll end with this thought. Your domain name. It's not just a label. It is a promise. It's a promise you make to every single user that they will arrive safely and securely at your digital front door. So the question you have to ask yourself is, how secure is that promise?